Welcome back. Let's see the more common version of the chain rule, and we'll work through some examples together. So the chain rule starts like this. We've got a derivative of a composition of functions. That is, we're applying the function f to some other function g. In other words, we can think of f and g as sort of being, g kind of an inside function, and f an outside function that we're applying to the first. And the chain rule tells us that the way we handle this is we can take the derivative of the outside function, f prime, we evaluate it at the function g, not the derivative, just g, and then we multiply it by the derivative g prime of x. So the chain rule tells us how to piece together these ingredients, the derivative of f, the derivative of g. So let's look at an example we saw in the last video. If we've got this function y, that is the quantity x squared minus 2x, all raised to the 99th power. Here we've got an outside function, which is taking something and raising it to the 99th power. And then we've got an inside function, in this case x squared minus 2x. If we want to see how we can label these things as f and g to get the composition f of g of x, we could do it this way. Or if we just want to think about inside and outside functions, I think that's often easier. So applying the chain rule carefully, we will see that y prime is equal to, we use the power rule to find the derivative of our outside function. So it's 99 times something to the power of 98. That something is just the inside function. And then we multiply by the derivative of the inside function. Well, the inside function is x squared minus 2x, and its derivative 2x minus 2. So we recover the same answer we got before. Let's try an example. If h of x is cosine of the square root of x, we can recognize that cosine is the outside function. That is, we have cosine of something. That something, the inside function, is the square root of x. So the chain rule says take the derivative of the outside function, in this case minus sign, and what do we put inside that minus sign? We just put our inside function wholesale. We put in the square root of x. And then we multiply that by the derivative of square root of x, which we can take using the power rule, or maybe we remember is 1 over 2 root x. Well, what if I switch these two operations, the cosine and the square root? That's the next example. Here, the square root is on the outside, and the cosine is on the inside. So again, the chain rule dictates, take the derivative of your outside function, in this case, derivative of a square root is 1 over 2 root something, whatever's on the inside. So we put the cosine in there. And then we multiply by the derivative of cosine, which of course is minus sine. So that's our derivative g prime of x. Now, the last function here, I want to know the derivative of e to the power of x minus 1 squared. There's two ways we can handle this. The first, I think you'll see, is pretty straightforward using the chain rule. What I can do before taking a derivative, before doing any calculus, is to expand that polynomial in the exponent. So x minus 1 squared, if we FOIL, we get x squared minus 2x plus 1. And then, applying the chain rule carefully, well, e to something is our outside function. The derivative of e to the something is e to the something. Remember, we've got this exponential rule, but the special version of that for e to the x is the derivative is just e to the x. So e to the something, the derivative is just e to that thing. But then we have to multiply by the derivative of the inside function, that is the function in the exponent here, whose derivative is 2x minus 2. So that's the derivative of this function. Now, if we didn't want to FOIL first, then here we actually have to use the chain rule twice. And I'll show you how this shakes out. If we wanted the derivative of e to the x minus 1 squared, well, the derivative of the outside is e to the x minus 1 squared. But then the derivative of the inside is, well, the derivative of x minus 1 squared. And hopefully you'll recognize we've got this power of 2, the squared is the outside function, and on the inside, the function x minus 1. So to use the chain rule again, we would multiply by 2, the exponent would drop to 1, and then we would multiply by the derivative of x minus 1, well, which is just 1, using the power rule. And you can compare that to what we had for the first part and see they aren't the same. They better be, because, well, we did them both carefully. So please take a look in the book, try some other examples there, and we will practice this in class.